Hey people, let's see if everything's working. Sorry about that, was running a bit late, so we're slightly later than normal, but we still made it before the official start, so that's something, right? And indeed, as some have said, I need to clear off my screen, there's all kinds of wires in front of it. There's now like, I'm on the fiber internet. So, that's just the music. So let's look at the stats. The stats. We've got 0 dropped frames, and I've upgraded the bitrate. Oh, I actually hope my my GPU and processor is gonna do that just fine. Let's see here. Oh, my GPU encoder is at 24%. That should be fine. Good. Yeah, so we're now on 1 gigabit down and 1 gigabit up fiber internet. So everything should be better. Well, actually, I've been, you guys, if you follow me, you know I have this DIY cloud backup thing. And my parents, where my backup server is, already had fiber internet with 500 Mbit. But I, of course, had Ziggo with 40 Mbit up. So backups took a very long time, especially of my video files. So after I upgraded the line and everything was working, etc., I started a backup and it went with 55 megabytes a second. So video files, no problem at all. So let's see what everyone's saying here. What? We didn't start yet. I was running late. We ordered dinner, and normally it'll be there around 7 o'clock. But now it was there at like 15 past 8. So only had like half an hour to eat and get everything arranged, and yeah. 10K stream now. I wish. YouTube actually doesn't support higher than 1440p 60. I'll have to check if they maybe upgraded it to 4K 60 now, but yeah. But I did upgrade the bitrate. I used to stream at 16 megabit, and now we're streaming at 32 megabit. Do you see a difference? Is there a difference? Don't forget to slam the like button. That's greatly appreciated. Von Talken says, I think this is the first stream on the new internet. It is. It is. Oh, you also have 1 gig up and down from T-Mobile. Yeah, I'm on the eFiber network, and I have Tweak as my provider. And I actually like it a lot because they just gave me a dumb level 2 media converter. So it goes from fiber to UTP, Ethernet. And I just hooked up that to my router. I could put an SFP directly in my router, but it only has a single SFP plus slot, and it's already taken for my 10 gigabit link for the rest of the network, because it also does all my routing and things like that. And so I'm just using the media converter for now, but I'm getting the full gigabit, so yeah. Only receiving 12 megabits. Okay, so before I was streaming in 16, and now we're streaming in 32. But I'm pretty sure YouTube does all kinds of... Oh, wait, I didn't hit recording. Oh, damn, there. I forgot to record. That's why this utilization was so low. Yeah, okay, we're now at 47% utilization for the video encoders on my NVIDIA card. But yeah, so far I think everything's working great. I'm seeing zero drops, so that's good. John Richardson says, I think YouTubers uploading 720p is just sucking up... Oh, above 720p is just sucking up bandwidth from the world unnecessarily. I wholeheartedly disagree. I sometimes find it hard to watch 1080p even. So, I'm not sure what kind of monitor you're watching on there or when the last time you saw an eye doctor, but 720p to 1080p and then especially to 4K and then 60 FPS, it makes a big difference. You don't need to see their dirty pores, but I scrub them every day. So, I even went to the barber for you. Look at that. Look at how clean that is. Hey? I got my hair cut. So, trying to look all pretty for you there, John, but I guess you don't appreciate it. Ultra drink! I need a drink. May I ask which LDO you're using on your booster board? On your site it says it goes up to 48 volt. It does. But there's many that do. But I don't know from head. Best is to come to the Discord, Matteo, and I'll look it up and I can tell you there. You should have a beauty pass to stream above 720p. Well, I have an ego pass, so I know I don't pass on beauty, but I have plenty of ego to compensate for that. So I'm allowed to stream at 4K, but YouTube can't do that. It basically can't handle my ego, so yeah. We settled on 1440p 60. I'm just having a laugh with you, John. I'm assuming you're doing the same, so don't worry. No admins today. I don't know. Maybe they called in sick. Which are the prototypes today? Von Tolkien? It's the exact same prototype as we had before. But now, the new version. Where is it? This is well prepared as always. Okay, the prototype board is here, and then I should have a stencil. But first, I think we need an ultra drink, right? But okay, let's take a quick look at the new prototype board because a lot has changed since last time. Better clips. Clips? What clips? You mean the connectors? Yeah, I switched to screw terminals. So let's see if this is working. Let's zoom in. And we're going to take a look at the new microscope today. I got a new HDMI microscope. And I'm sorry to say, it is 4K. Let's see, this way about. Yeah, there we go. So a lot has changed because I removed the LDO. We now have a buck converter on there. But it's a new buck converter I've never used before because it does 200 milliamps max. And you'd say, why do you need a buck converter for 200 milliamps? Well, we tried the LDO last time, and that was getting pretty hot and very inefficient. So it's like, okay, if I can get a 200 milliamp buck converter for 5 cents, maybe that's worth it. Maybe that's worth it. So that's what we're going to try today. So I have a little buck converter and a tiny little inductor there. And then we still have one of the resistor networks, but I changed all the others to individual resistors and capacitors, because this is also a prototyping board in which I want to change those resistors and capacitors. So it didn't make sense to have resistor networks there. That kind of just complicated things. I fixed the circuit like we were bodging before. Where is it? Where are those? They should be here somewhere, I think. Did I clean them up? Might have actually cleaned them from my desk. I can't imagine I did. Yeah, don't know where they are. Oh, I probably have them in my office because I was redesigning them. I don't know. Maybe we'll find it later. But yeah, lots of changes. Some of the layout is still the same. Some is different. We went to 5.08 millimeter screw terminals for all of these screw terminals now. Still have the input switcher, so you can have the input on the top or on the bottom. Still have fuse, and yeah, we'll see about that in a bit. Let's see here. I have that big D energy. Is it pink? It's not pink yet. Pink costs extra, man. Will do, thank you. The reason I ask is I can't find an LDO myself that can lower such a high voltage to 3.3 volt. Well, Matteo, there's a thing that people often overlook with LDOs. Even though it says it can take, let's say, 48 volt in, I believe this one's up to 80 volt actually, it doesn't mean you can actually use it. It all depends on how many milliamps you're going to use. Let's say you want to put an ESP32 behind that LDO. That means that LDO might see 300 to 500 milliamps. And then you have to calculate how much energy or how much power it's going to burn off going from that high voltage to that lower voltage. So let's do a little bit of math here real quick. And that's also why I switched to the buck converter here, because we're using a little bit more energy than I initially anticipated. So let's try this. So let's say we have 24 volts, right? No. Let's say we want 10 volts. On this board, we want about 10 volts. But we have 24 volts in, and let's take the 10 volts off of that. That means we need to drop 14 volts. Okay? Right? So we need to burn off, if it's an LDO, we're going to burn off 14 volts. And now let's say we're using 100 milliamp. Okay? We can say, okay, we need to drop 14 volt times 0.1 amp. And that is, I don't need a calculator for that, but let's do it anyway. No, times 1.4 watt of heat. So dropping 14 volt with 100 milliamp of load means we need to dissipate 1.4 watts of heat. And then you can look at how well the LDO can transfer heat to the board. But in the end, heat is heat. So it doesn't really matter how well the LDO can transfer it in the board. You're going to need to dissipate it. And well, it depends on the situation if that's suitable or not. At some point, especially like this, if you're dropping this much voltage, even if it's just 100 milliamp, remember an ESP32 will do 300 to 500. Yeah, that's just not going to work because it's just going to go way too hot. And that's also what we saw in the other prototype. It was only drawing about 100 milliamp, but because we were using an LDO and dropping it, basically burning it off, the board heated up to 50 degrees just on idle because, well, the heat had to go somewhere. Now, if you're using a buck converter, you're not actually just burning it off. It does switching and things like that. So it's like 85, hopefully 90% efficient. And thus, you're not burning off 1.4 watt, but you're only burning off 0.14 watt, for instance, right? So, yeah, so even if the LDO can take a very high voltage in, it doesn't mean you can use it to run any kind of load. You always have to calculate the heat being generated and if that's acceptable for your situation. Maybe you'll say, oh, but I'll run some heat sinks and a fan on there. Okay, well then maybe 1.4 watts is acceptable. But if you're running this in a closed box and there's no fan, no heat sink, etc., well, maybe the PCB will get 70 degrees. That might not, I don't think that's acceptable. So, just a small little bit of theory here. Looking for another job. Yeah, I don't know about... Oh, CJ's here. So, Matthew Koning, I hope that kind of explains why high voltage LDOs generally aren't a thing. Because their usefulness is very limited and you quickly have to move to a buck converter, basically. Now I'm annoyed that I can't find my prototypes. Maybe I put them away in the right spot. I actually did. They're in my overflow bucket again. Oh. Okay. So let's do a quick comparison here. Yeah, you can't really see anything, right? Well, maybe. So this is the new prototype, and this is the old. It's a bit dark, isn't it? That's more light. There. Well, as you can see, stuff really moved around. This terminal moved, and the fuse moved, and all the outputs moved. Everything moved. I basically redesigned the whole thing. But that's what prototypes are for. You learn from them, and then you adjust. That's also why I changed from... I was hoping I could use the buck converter. It was getting way too hot. And maybe I can fix the idle draw with a circuit change and different resistors. That's what I'm going to try. But, you know, we'll see. So, first we need a new drink. I don't think we need a poll for that, because we only have the usual the usual suspects today. We have the vanilla and the cherry. I'm feeling vanilla, so it's going to be vanilla. Oh, no, wait, I'm feeling cherry. That's what I meant. Let's ultra that up, because, you know, a drink without ultra is just like, what are we even doing? Oh, this is a very classy ultra. Let me widen that up there. High quality print. Go. Wow, look at that ultra. It's a high class ultra. Look at that. Look at that resolution. I'm really amazed by thermal printers, how great their resolution is. It's awesome. And this isn't the, you know, if I make it wet, this isn't ink. It's a thermal printer. That's how labels are printed. So it's basically like a laser melting this on there or off there. Not sure which of the two. But there's no ink involved. So that's really cool. You're addicted to Coke vanilla and vanilla cherry. Vanilla cherry? What? I think I made... you heat it. Yeah, then it'll turn dark. You have like 50 Dymo printers. Oh, well, this is a brother, but... Wow, you're printing a lot of labels there. You're label crazy, yeah? I was going to say, 50 label printers? Holy shit, I have one. It gets well used. I have to admit that. But, holy shit, 50. Label your 4 in case you get drunk. Okay. So now we have the Cherry Ultra. Let's enjoy that a little bit and then get started working on this prototype, because it's going to take a while building it. Are your label printers labeled? Well, mine isn't. It would be label 1. Yeah, this one has an auto cutter too. I just have a continuous tape in there. Work, home, country, homes. What? Orange vanilla in the US also. Orange vanilla. I don't know about that combination. I think we combined vanilla and cherry once. It wasn't a great success, but I'm not sure. Maybe if they do it in the factory, it's better. Oh, Matteo Koning actually responded. Okay, but you shouldn't exceed the max input voltage in the datasheet, right? Because you indicate on your booster board that it's rated for 48 volt and I cannot find an LDO with such max rating. Yeah, no, you should never exceed the max ratings in the datasheets. But there are LDOs out there. But then you have to make sure it's drawing very little power, like the data booster, because otherwise it's just not going to work, like we saw on the previous prototype. Mountain Dew is available, but not in the generic shops. Maybe if you live in a big city, but I live in a small town. So you'd have to special order it probably. Orange vanilla is also called creamsicle. That doesn't sound nice. Yeah, the Mini is still on the roadmap there, Draadstal. I actually designed it a few years back, but I never released it. But I think there's a need for them now, so I'm working on a few of those things. Some of this might be closely related to the secret we're going to show today. That's not a hint at all. Coke Starlight? Never heard of that. Tastes like outer space. Well, then you don't even need Ultra. You can just outer space it. No. This one actually didn't smoke. It's a other prototype I'm building, and I'll show it first, and then probably a live stream later. We're gonna look at it. Your goat leggings? What? Right. So I need to prepare a little bit because I still need the IBOM file. Let's see here. KiCad stuff. With the Dig Uno, I want to run a relay to kill the big power supply. Can I run 12 volt through the main input and 5 volt to the pins next to keep the board alive? Yes, built by Ross, that is fine. Uh-oh. I generated my BOM file, but it's coming up empty? Why? Uh-oh. Did it again. One moment, please. Maybe this version of KiCad's too old? Uh-oh. Well, that's a new one. The IBOM file is coming up empty. Okay, let me try and update KiCad. We'll have to download that real quick, but we now have fiber internet, so it should be like done instantly. Okay, 2 minutes left, it says. BOM file empty means very cheap to build. That is true. Got some of those 24 volt addressable neon light strips and a Dig Quad. Isn't compatible. Yes. If it's one of the more recent Dig Quads, and then I'm talking like 1.5 years, it should say on there that it's 5 volt to 24 volt compatible. No problem. What is the background of everything called Dig? Well, not everything's called Dig, because I also have AN boards. And the Dig boards stand for digital, because those are all digital controller boards for digital LEDs. I also have AN boards, which are analog boards to control analog LEDs or dumb LEDs with PWM. Ooh, 10 seconds left. What are we building? We're building a Dig to analog, actually. So we're taking a digital signal and then we're making 4 PWM signals from it to run a analog or dumb LED strip with PWM. So you can basically treat a whole LED strip as a single pixel. Now, let's see if we're going to drop some frames here, because then we're going to try and install KiCad while we're streaming. It's always the best idea. I'm hoping this version upgrade does it, because otherwise there's going to be a problem. You can dig AN, okay. Yes, we're making smart stuff stupid again today. That's right, Draadstal. John Koester, hello. Uh-oh, we're doing Microsoft runtimes. I hope OBS isn't using those. Just one moment for the install to finish. What do you think of the Govee M1 strip? I think it's a very generic WS2814 strip that they're selling for 3 times the price. So if you go on AliExpress and you look up WS2814 and then you get a 60 LEDs meter 24 volt strip, you basically get the same thing. Except we've had those for years. Now, I haven't taken a very close look at the Govee M1 strips, but what I saw online and from other videos, the chips on there actually say they're WS2814s. So, yeah, there's only so much WS2814. Actually, the thing we're building today also has a 2814 on there. Okay, I've updated KiCad. So now I need to update the plugin. Govee has pulled wool over the eyes of the world. No, I get they give you a functional package. I don't believe the Govee stuff is bad. It's just that if you're able to do it yourself, you can do it a lot cheaper. Okay, updating the interactive bomb thingy. Okay. Whatever. Okay, I think let's uh-oh. Where's my there? Let's see if this works. And otherwise, I need to go to my other computer, and that will likely work. So, interactive bomb, generate. Yes, it worked. Okay, cool. So, let's close this. Okay, let's do this. And let's go here for now. We might change to a different view later, or actually pretty soon, but we'll see about that. So here's the bomb. And I believe last time we learned that if we double click here and here, yes, it'll reset them all. Oh, so nice. Now I don't know the standard sorting, because now it's not sorted. I think I need to sort by footprint. Wait, it's not. There. Okay. I hope I got these capacitors. I'm not sure. Okay. I'm trying to think how I can show you guys everything. Let's do it like this. No, that's very small. Yeah, we're going to do it like this, but we're going to change views. Let me get something out there real quick. No, wait, no. We need to paste it first. No, there's currently no addressable LED strips that have RGB plus CCT, so selectable white, that I know of, or that is generally available. Zappy Zap Zap. Hello, Quindor. Just a quick hi from Canada. Hello there. The Z strips. I don't know what Z strips are, but they have 4 pins. Okay, well, maybe they're doing analog white actually on there. Right, so first we're going to paste this thing up. So we're going to take the stencil out. Don't know if my address is on there. Don't think so. Nope, that's good. So let me get this stencil out. There we go, that's a stencil. And I need to get my stenciling board. There we go. Don't need this anymore. So we always have to adjust the size for whatever we're making. As you can see, the thing I was making before this was very small. It was only the width of a finger. Hint, hint. Well, look at that secret all the way at the end. Don't know how long the stream's going to run, but we'll see. So then we take a little prototype here. Put that in there. We need to look at the stencil, how it's oriented, because that sometimes changes. Come on. Let's see. We have the big capacitor and the fuse there. So it goes on like that. That's good. That means I can squeeze this in there so it's like in there tightly. And then I can tape this down again. Over here also. And now this is basically locked in there securely. That means we can take this guy and orient it exactly over the pads. Something like you need to do this exactly because there's very tiny solder pads on there and those need to all line up. So what I'm basically trying to do is make sure there's no green visible anymore. I think I got it. I often get some extra tape. To also stick down these sides with a little bit of tension. Okay. Now we get my bucket of paste. So I'm using Chip Quick TS391LT50. That is low temperature paste that doesn't need to be refrigerated. Let's see if it says it on here. That's a 2205. I might need to replace this at some point because that's over a year old now. But it's 138C paste. And we're going to use these tools. This is to get the paste out of the tub and spread it on the thingy or on the stencil. And this is to squeegee it out. So, let's see. So I used this paste earlier this week, so I don't need to stir it. So I'm just gonna dab some on there, like so. And that's the nice thing about using a tub like this. You can basically just only use what you need and reuse it later on. So what we're gonna do now, we're gonna make it into a nice, nice ball. Don't have a lot of room on this stencil. We're going to make it into a nice bead like that. And then we're going to hold it at an angle, squeeze down really hard, and go over it like that. Yeah, that looks perfect. Nope, other way around. So that filled in all the little holes, including the very tiny ones there at the MOSFET, for instance. I think it got them all. Yeah. Okay. So then I take the paste off again and, put it back in the tub. We'll take a look in a minute if I did a good job or not, because this camera zooms in pretty far, but this is the furthest it will zoom. So let me clean up my tools and get my new microscope online. Okay. Is everyone so mesmerized by me doing stuff that they've completely stopped chatting? You have to clean your tools well if you want to use them more often. There. Okay, so this can go. Now we're going to try and remove this without smudging it. Built by Ross. Yes. Nice. Okay, and we should be able to just flip this up now. Ha, and there we have the beautifully pasted board. Yeah, that looks good. So let's take that out. I'll show you an up-close view in a minute. Bear with me here while I clean stuff, because I also have to clean the stencil. You're amazed at the single pass pasting. Takes me 20 with a credit card. Yeah, I used to use a credit card, and it can work. You can get decent with it, but I don't have a link right now for that spudger and how do you call that other tool? The spreader, I guess. But those are gold. They're not very expensive, but they work really well. Have there been any thoughts in making a dig-to-go with screw-down terminals for connecting LEDs? No, because then just get a dig-to-go. Sorry, a dig-uno. I mean, I'm not sure what you're looking for there. Okay, let's get our little cork surface here. Put it on there. And now let's put the board away. And now let's get this thing out. Let's see if all the wires are tangled up. Seems okay. Okay, turn on all the power. This circuit mount stuff is awesome. I actually enjoy watching others do it. So that's like, you know, why I try to stream it more often now. So, let's see if I can get a camera here. No. No. Yes. Let's see. Reset transformation. There. So this should be the view from our microscope. Let me turn on this light here. Oh wait, it's turned off. There. Oh, I didn't do a great job pasting. Could have been better. So that we can, this is a microscope with a variable zoom lens, because I always hated not having one. Let's do a little bit less light. There. So this is the board. We got some pads down here, over there, and over here. But as I said, this has a variable zoom lens, so I can actually zoom in quite far. And you can actually see the solder balls in the paste. And you can also see that I slightly misaligned the paste because all the top parts of the pads are missing and it's all on the bottom parts. But, I mean, with the naked eye, it's impossible to see that. And over here you can also see that there's only a tiny little paste on those little pads over there. So much cooler than when I learned soldering back in the 80s. Well, you can get so much more stuff on the board. Oh, I didn't realize the microscope would be blocking my face. Hey guys. Yeah, now we can see the shoddy paste job, right? Because I thought I lined it up pretty well, but especially on those small pads there, could be better. And they're all misaligned. Still, this, you know, it looks worse than it is. This will auto-align very easily. But, you know, you're here with me. So we're going to, you know, put all the components on there and then reflow it, and then we'll see. Right? So, let's get started with that. You can see me mess up again. All the previous boards worked except for design issues, but, you know, we'll see. I actually really hope I can find all the components in time, because they're all scattered everywhere, so I just don't know. Let's start with this one. 0.1 UF0402 capacitor 0402. Put this over here. Sure. Let's do these. Oh, I don't have my normal surface here. Didn't think about that. Okay. I need some tweezers. Have to go full screen for the detail work. No room for chat. Well, there's nothing. It actually works out on this board because there's not much on this side. So, you know, you can also see how crooked my my tweezers are actually are. It's okay, but could be better. I didn't think about this. Now I don't have a surface to put my components on. Interesting idea. Interesting problem. Okay, let me get my silicone mat real quick. Hold on. Yeah, that should do. That should do. Okay, I need, for this mouse to stay put, I need 7 of those capacitors. You can't see that because I'm trying to show what I'm trying to do on the board. Let's start at the top. And it's the third one from the top. Oh no, it twisted in my capacitor, in my tweezer. Now you can see how horrible my component placement actually is. Oh, I'm actually not showing that part. There. But reflow will fix it all. They should go all in the same spot. I move my mouse. Okay, one goes over here. And the last one goes down here. There, now let's see how horrible a job I did. So if you look at it closely, you're like, well, this one's pretty good. But then you're like, what are you doing, man? Can't you even see the pads? This one's pretty good. That's fair. So let's give this one a little nudge. But we'll do this at the end because we're going to be putting components close to that. So, wait, which one is it? This one? Yeah. There. We're going to be putting components close to the things all over the place, so we'll do the final alignment before we reflow. That's fair. Yeah, I really wanted this this zoom function. It's a mechanical zoom or an optical zoom. Works really well. Let's see, 10UF0603. $25 volts. Oh, okay. Yep. We need 3 of those. Since I need to do a lot of component rebagging anyway, or reordering, I'll skip putting them back where they go for now. I'll do that during the week sometime. You have pretty good eyesight. Thank you. Yes, I have very good eyesight, actually, because otherwise doing this would really be impossible. Because I do use the microscope for the final alignment. Before I used to use some magnifying glasses. I also had another microscope, but it was just too big for on my desk, so that really didn't work out that well. There we go. (2.20603). $50 volts. Don't know if I have those. Let's check the new arrival boxes there. $2.250 volts. Yeah, it really depends, Monty. I have that problem too sometimes. These are officially, I don't know if they are actually titanium tweezers, and I've had really good luck with them. You can find them on AliExpress. They're like $10 a piece or something like that. But I've used a pair for over a year now. This is a new pair actually recently, but I've used another pair for over a year, and the tips stay really good. So this goes down there. And this is what I was saying. If you're placing other components next to it anyway, doing final alignment really isn't going to work. Okay, okay, I do want to move this slightly. There. We'll do that later. We'll do that later. Is that all the capacitors? Yes. Okay, next we'll do resistors, because I have that box right here. $5.1K, lots of them. Yeah. First bag, first try. And cleaning the tip also really helps. And I kind of abuse the cork surface for that. Hold on. 6. 1, 2, 3, 4, 5, 6. Because what I do, let me move this out of the way, is you have this cork, and I just jam them in there. I wiggle them around a little bit, and I pull them out again. And that generally perfectly cleans the tip. Okay, there's some stuff there now, but That generally cleans the tips perfectly. But as you can see, my alignment isn't perfect already. But it's not that bad either. There. 5.1K is everywhere. One goes over here. So all the way to the left for the LED, I just placed it. And the others go near the LEDs, I think. Oh, one goes here. There. Yeah, and the next is all on the LEDs. Above the capacitor we just placed. It's also part of having a oh no, there it is. A good paste job on there. That really helps. Because basically I also have the problem if it's sticking to the tweezers, except when it hits paste, and then it generally lets go. Need one more. Okay, it's not great, but it's getting there. Yep, had all those. 1K. As I said, normally I put the bags back immediately after using them, but to save a bit of time during the stream, I'll do that later. Let's see, 4. Does anyone have the same experience with AliExpress? My order at max track 10 to 12 days and sometimes only 5 days. But you mean that they also get delivered in that time frame, or the tracking just isn't there? Because it will really depend. If your package is on a boat, they won't be able to track it while it's on the boat. But if it's going by plane, it should be pretty fast. Come on, flip the right way. Okay, last one. I know. It all looks crooked. I know. Oh, we need some 0 ohms, right? I hope that's in here. Yes, it is. Yes, delivered to the Netherlands crazy fast. Yeah, my experience has been that for a while now it's been pretty fast. It's certainly not like months like it used to be years ago. Okay, now we're doing 0 ohms. Oh no, I made a mess of it over there. There. Should be good enough. Please stick around for the magic of the reflow. Because with this microscope you can see really well. It's partly magic. Although I won't be able to use the reflow plate under the microscope, but we can check it later. Let's see here, 2.2K. You think the storage is in your backyard? What's wrong with this bag? Okay. One. You only need one? Okay. Oh, come on. It just loves to flip the wrong way. Come on. Get on those pads. Nope. There. There we go. 33 ohms. Okay. And it goes over there. $113. Your nervous order from AliExpress? Well, you certainly haven't watched my Quinbox series. If you're nervous about ordering on AliExpress, watch my Quinbox series and you'll see that I order hundreds of packages a year from AliExpress. Okay. There. We need a 10K. 5%. Oh no, I want a 10K 1%. Do we have a 10K 1%? Oh no! Well, that'll throw off the regulation a little bit. So this is a 10K resistor. But it's a, well, I can't really show you that well. 5%, as you can see over there. What that means, it's within specifications 5%. But this is for the buck converter to determine the voltage it needs to put out. So 5% is kind of a big range for a buck converter voltage setting. So you kind of really want at least 1%, if not better. But I have that wrong in my component list, so I didn't check it. And it really depends. Like if you use a 10K for a button pull-up or something like that, it doesn't really matter if it's 5% or whatever. But for this specific purpose, it does. Right. Okay, I need a 1K resistor network. I think those are in here. What type of buck boost converter chip do you recommend for a custom 25 volt, 24 volt board? Wow, that is a very, very broad question. The right one. And which one that is depends on many variables. So I really can't just tell you this one. We're going to use this later. We're going to use this later. Right. Resistors. Oh, we're going to use this later. This is the previous prototype box. So, yeah, we'll need this later. Need that later. Oh, here they are. Okay. So yeah, the percentage of the resistor and how accurate it has to be really depends on what it is for. As I said, button pull-ups really don't care. Could be even 10% out. But for a buck converter, you really want it very tightly regulated. Which now it won't be, but should work well enough. I don't need a perfect 10 volts in this case. So this goes over here. Let's zoom that one in a little bit. There. That's pretty good. It's in both the solder pads. And they'll straighten out during reflow. Should be fine. Oh wow, Gary. That sucks. Why is there a hair here? There. Okay. Let's see here. Okay, we'll do the WS2814F. What did you jinx there? And let's see where pin 1 goes. Pin 1 goes right at the top. Sometimes I swear when building stuff, half of the time I spend flipping chips upside down. Okay, the dots over there. So last time this footprint didn't fit at all. So I gave a bit of a manual spin on it. Oh, it still isn't great. It's still out. You see that? That's not going to line up, but it'll line up enough. There. This should solder all of the legs. Maybe a slight nudge here. There. That should solder all of the legs. Still a bit too much. But it's still not correct, as you can see, because it's out on both places. Right? But that'll work. It'll work. Okay. Well, let's do some of the things I just got out. Let's do the switch. That one's over here. It should be easy. There. That'll reflow. Let's do the fuse. That one's over here. There we go. Oh, we need to do the LED. Right. So, I need to check the orientation. Is there a dot? There is a dot. Yes. So the LED goes over here. And there should be a little dot on the board to which the tiny side of the stripe needs to go. So, if you look at the underside of the LED, you can see that it has a wide marking across it and then a tiny point there. That tiny point needs to go towards that little dot. So I need to turn this around. Remember where it is. And kind of place it like that. That should work. Think. We'll see. Let's see what else we need to do. The capacitor. I think I have that over here. Yes. Or the big capacitor, actually. No, because that will make reaching these pads harder. And I need to do those too. So I need to get a diode. And I need this diode. Oh, it's a new string. Interesting. I hate these plastic tape things. I like the paper tape a lot better. There, I think I got one out. I did. Oh. Okay. And then there's some stripes on this diode. Let me show you. There, you can see those stripes at the top there. That needs to go into the little box. There. So now we need the... Oh, I already did this one. Don't need to do that. We need the inductor and the actual buck converter. So let's try and find that. This is going very well so far. Is chat stuck? Yes, maybe. Well, it's not on my end. think everyone just gets mesmerized of me putting components on a board. So let's get one of these buck converters. I was really amazed when I found this little guy. It's like 200 milliamps. 200 milliamp buck converter. It's kind of stupid, really. But then again, it's only 5 cents. I mean, can't complain with 5 cents. My LDO was more than 5 cents, so... Right. We need to find pin 1. Pin 1 should be at the right top, and normally then there is some kind of marking on there. Not so far. Well, it depends on the kind of light you have. Let's see, there. In this light you can see there's a marking right here. Right there. So that should go on the top left. Close enough. And then we have an inductor. Okay. And we should have a big capacitor. No. Let's place the MOSFETs first. So let's take these off. Tick. Oh wait, I take these off. That's wrong. There. Everyone just quietly watching there. This is like Zen night with Quinled. Oh, that's 5. Don't need 5. Okay. This is that special type of MOSFET again, which has, let me show you over here. If you look closely at the bottom side, you see that's actually 2 N-channel MOSFETs in one. It's very cool. And a tiny, tiny form factor. So we need to get that turned around correctly. And then we put it in place. Now this footprint already worked pretty good the last time, but I've since improved it a little bit more. There. Yeah, I hope so, Dradstal. That should be fine. So, I believe that is the last of the SMD components except for this big cap here. I'll place that last. So let's take a closer look and see if we need to nudge anything to make it reflow. This one could use a tiny little nudge. There. Other than that, those look fine. This one isn't touching the other solder pad. there. Okay, slightly move it. Yeah, that's fine. That's fine. Let's look over here. That's fine. It's all fine. Okay, let's look at this guy. Oh wow. Okay, that's better. There. That should do it. This one's a bit too far down. There. That should all work out, I think. Could be better. Sure. Fine. Okay, should work. Yeah, we still need the big capacitor, okay. This one needs a little nudge. Okay. Yeah, reflow should move all this on the pad, but you kind of do want them to touch both of the pads, and then generally it should work out. Is the voltage drop across the buck converter low enough to power the circuit on 5 volt, or are you using it to drop the voltage down to 3 volt? This buck converter is actually converting to 10 volt, so no 5 volt operation here. I'm using a very different circuit than other boards have used before it, because I believe to do it differently. There, big capacitor in place. So let's hit that guy. And then we should only have 2 whole components left, and that's the screw terminals. Good. Let's move that one away. Let's turn that one off, because now we need to move the microscope a little bit. There. I need this plug. My desk is a giant mountain of packages again. But that's okay, that's okay. Let's get our reflow plate. Leon van der Meij. Hey Q. Hey there, Leon. Let's look at our dirty surface over there. Oh no, we do have to turn it that way. Let's turn it on. This is still that modified plate we did a lot of streams back. And it's awesome now, because it's like drawing 328 watts from the wall, so it's going to heat up really quickly. Okay, this is the furthest I can zoom in for now. Well, I can make it a little bit bigger for you guys. No, don't do that. One moment, please. There. That should be big enough, right, to see everything reflow. Okay, we're already at 45 degrees. Where's my drink? 60 degrees. Still drawing 327 watts from the wall. I believe the original heating elements only did like 150 watts. So it's really fast now for this tiny little... until it trips the breaker again. Yeah, well, we fixed that isolation issue. Turns out non-conductive heat paste will conduct 230 volts AC. Who knew? Well, now we know. But since I fixed that, it's been great. Yeah, the girlfriend was really like, stop tripping the breakers already. Oh well. Let's move this a little bit. There. See, I even made a little graph here for the resistor switcher. See that? Oh. But the text is all way too small. When I'm designing this on my 48-inch giant screen, it's like, oh, that's easily readable. Everyone can read that. And then when I get the prototype board, I'm like, what? What was that supposed to say? No clue. Oh, it's starting, it's starting. Come on, components. I already see a few that need a nudge. So let's start nudging. I feel like this guy needs a nudge. There. That needs a nudge. That needs a nudge. See how this straightens out? That's awesome. This needs a little nudge. This all looks good. That looks good. Good. The resistor network looks good. Even the WS2814 looks decent enough. These all look to be on their pads. We can give these a little tap. There, 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 and there. That should make any solder that's trapped underneath it come out. Capacitor looks fine. Wait, did I place the capacitor? Yeah, I did right. Yeah. Minus is here, plus is there. Yeah. Okay, that's looked good. This looks fine. Slightly crooked. There. Yeah, we'll look at it under the microscope too. But so far, right now, this looks fine. Now comes the hard part. Moving the board and not wiggling it and dropping it too much. There. I think I did it. Oh! Now the LED's on there. Let's quickly take a look. There. And there. So let's zoom in as far as we can. Wow. Yeah, I'd say the LED is on there perfectly fine. That's good. Okay, that's way too much zoom. There. Yeah, that looks fine. Actually not sure if the paste melted completely there, but it should be fine. Maybe it's the angle. Probably the angle. Okay. Capacitor looks, or the diode looks fine. The big capacitor, fine. The big fuse, all good. Where are we? Oh, over there. Yeah, that looks fine. That looks good. Good. Here you can see the WS2814, that my footprint still isn't correct. Because you see that it's slightly overhanging over here still on the left side. But it's also kind of overhanging on the right side. But it's a lot better than last time. So I need to do some little corrections there, but that's fine. Here we can see that all the pads soldered good. There's solder on those legs here over there too. This one is a bit thin, but there probably just wasn't a lot on there. I can correct that in KiCad, the amount of percentage that the pad gets pasted. There's a little solder ball over here. There. Ow. The board's still hot. Let's see if I can pick that up. Well, good enough. Okay. That's fine. Those look fine. See, even though they weren't on the pads very straight or perfectly at all, as long as they're touching both solder pads, it'll pull it in straight. That looks like all the legs are also perfectly soldered. Maybe a little bit too little solder on those side pads, but that's fine. Because they're very big pads underneath, and there'll be solder there. Yeah, all good here. Oh, that capacitor where the heart is, slightly misaligned. It's okay. Yeah, all good. Let's see over here. Well, this resistor could be better, I guess. Yep. That looks all good to me. What do you think? Yeah, the zoom's nice, right? Because you can work at it like this. And then you have a decent overview to actually place the components. And then if you're like, huh, how well did it place it? And then you can really look at the leg and everything. So you can even, so if I move up, you can see that the top of the chip is now clear. And if I move down, you can see that the solder dots, bridge, legs, whatever. Oh, here's the resistor network. That looks good too. Yeah, this is the right kind of zoom, right amount of zoom for me. Right? Because I want both. I want both this zoomed in look. Oh, look, there's a solder ball there. I want both this zoomed in look and I want the zoomed out look, basically. And I need to improve a little bit on the lighting because this doesn't look great. But the reason why I got this exact version of the microscope, and it is linked in the description, is, let me show you on the face cam, the working distance, right? So this is an easy, well, what do you call it? I mean, my whole hand fits in here. So the microscope isn't in my face because I can easily look down here instead of if it was down here, I'd have to, you know, look underneath the microscope. But I can still stay on my normal level while looking at the board, and the microscope also has a good view. So I had one of those trinocular ones. It's sitting over there. But the camera on that one wasn't great. And, well, I found that I didn't really use the eyepieces. I just wanted to look at the image after it was completed. And this one works a lot better for me. And it's currently in 4K 30. I think it's good enough. It's supposed to be able to do 4K 60. But I haven't been able to switch it to 4K 60 yet. But this image is, well, I think it's quite good, right? And I love the optical zoom feature. So I've only been using it about a week, but so far it's been pretty good for me. Yeah, anyway, this is fine. No need for corrections. It's like magic. It doesn't come with the stand, but I have both the microphone and the stand linked in the video description. And I haven't done a video about it yet, but I might at some point. Because, you know, I tend to do videos about stuff I like. Right, so let's get some screw terminals. Let's hope those fit, because I moved everything on the board around. I mean, let's hope the buck converter does anything, because that's a whole new circuit. You know, lots of questions. Okay, so we need to merge two of these. There. Let's hope those fit in their spot. Yes, they do. Looks like I got those footprints correct. That's always good. Last time we had a problem with them not fitting into the board, and the footprints were an issue, and you know. So it's going to end up slightly like this. In the end, I'm probably going to use a different capacitor there. A bigger value, basically, because if you look at the screw terminals are higher anyway, so I can just use a higher value capacitor. Hey there, Emil Bart. We need a video about this microscope. Oh, sure, I'll make one. Okay, so let's flip this around as best we can. There. That's the nice thing about them all being the same height. We need the soldering iron. Yeah, that's it. Okay. I'm again not going to use a fume extractor because I'm just can't be bothered right now. I'll keep blowing on it. Yeah, too much stuff here. Right. I can't really move it, but I can move this. There. Let's see what kind of tip I want. I think I want this tip. Do you know the shawarma snack bars in Os? And in Os you have the Oostwal. And the other one, the real shawarma tent, burned down. You just had a 2-hour rave at a similar one in Purmerend. How does that work, Emil? That's a different city. I don't know. So let's do data first, because that shouldn't have a lot of copper. Or rather, that should have a very small board connection. Okay. And then let's do one of the channels here. And I don't know, plus over here. There. That should be good enough to see if they're aligned. Let me check. Yeah, that aligns pretty well. They're all flush to the board. Good. Now, one of the things I'm noticing is that there's a slight spillage over here, and over here, and over here, and over here. So if I'm going to go with this brand of terminal, I could probably move them back just ever so slightly, as you can see here, and then keep it all within the boards. This is an RGB-WW version, Gary F. So these are RGB-W, but I think you mean maybe RGB plus CCT. So 2 colors of white. And in my opinion, RGB-WW is the wrong term for that, because that is the term to describe RGB warm white, not RGB white. So if you want RGB plus 2 colors of white, it's best to call it RGB plus CCT. So this will have 4 channels. So basically we'll do RGB plus AW. But not 2 whites. Okay. That looks good. For anyone wondering, this is solder with LED in it. It's actually from AliExpress because I'm testing it. My soldering iron is set to 380C. But even this this pad over there, the minus, that's connected to 2 ground planes. That did pretty good. Yep. Okay. Yeah, the Sphinx next to the Oostwall burned down, that's correct. I believe it was the Sphinx, I'm not sure. I'd just like to interject for a moment. What you're referring to as WW is in fact RGB. Yeah, that's what I just said, wasn't it? Didn't we mean the same thing there, CJ? Or is the stream lagged a lot? I don't know. How are my stats doing? Oh, we still have 0 dropped frames on the network, and we're doing twice the bitrate. That's awesome. Oh, okay. So, these are... Did I solder the data pin? Yes. See, so even though this is AliExpress solder, I think that does very nicely. So we have the little switch here. That's good. One of the things I like is that all the components are actually nice and protected between the screw terminals, so you can't really touch and reach them. I also like the quality as a microscope. I mean, come on. That's pretty good, right? Okay, anyway. We're done with the microscope. We're going to go to the actual testing now. So let me disconnect this. Let's turn this off. Higher. Okay. Let me unwire the giant mess on my desk here. There. Let's keep that. There. No. Yes. The brand for the solder is High Quality from Best Solder, but it's a special version. I'd have to look it up. Let me look it up real quick, because I really like it. I mean, I often buy stuff to test it so I can list it, but I haven't listed this one yet, I think. But this one does really well. So I got the 6mm version of this stuff. Or the 0.6mm version, sorry. It's not cheap, but as I said, works well. Well, you just saw it work, so I mean. And the microscope, as I mentioned, is in the video description. Yeah, 0.6. Yeah, 0.6. Yeah, 6mm solder is like for welding. It's not for, soldering. Okay. Should be like this. This one should be down. Right, I should have a dig quad somewhere. It's over here. Okay. And then I need wires for in here. Can't open that link for some reason. Might you be in Germany? Okay, I need a female lead. Or a male, I don't even know what it is. Nope, in the US. Oh, okay. Well, I guess they're not allowed to sell to the US for that product then. Or you have an ad blocker. Because sometimes ad blockers, for some reason, block my affiliate links. So we need to quickly prepare a little lead here, because I need more of these right now. So let's do that. Damn it, it broke off. So let's redo that. Yeah, it's probably a country thing, where your country doesn't like that link. Let's take these off. Now, normally I wouldn't recommend using this type of wire in between here, because this isn't going to have the voltage drop an LED strip would have. So you could easily overload the JST connectors with multiple boards, but we're only going to use one board today, so that should, in theory, be fine. So let's crimp this. There, and that should be on there pretty good. Oh, it's tin and copper, so SN6040. This didn't go well. And I have all the new types of LED-less stuff and things like that, but it's always a hassle. And this isn't a board I'm going to sell. This is just, a personal prototype. The ones I produce in the factory are LED-less or RHOS and blah blah blah, but my solar paste is too, actually. But, for home prototyping use, I like to have it easier. There. That should be good. Because then we can see down here plus data minus. Okay, so like that. I believe for flux it just says resin flux, resin core flux. Yeah, for personal usage, I mean, I get it, lead free and stuff like that, but I'm doing this stuff partly to enjoy it and partly to just, you know, build a prototype. And then if you're soldering and it keeps sticking and doing all kinds of crap, I get it for manufacturing, but for home usage, I'm just going to use a little bit of lead. There. Actually stuck it into the cork. So we have minus data plus. Good. We can link it again over here, but we're not going to do that. We need an LED strip. I believe we had some new RGBW CC or RGBW cop strip in previous live stream. So late! Oh no! But you didn't miss the turning on yet. Is this what I want? Oh yeah. No, it's not RGBW. RGB. Too bad. Hold on, there must be on the floor because it's a giant mess over here. RGBIC, no. Nameless bag. Yes. We unboxed this in a previous episode of live Quinboxed, or whatever we called it. And let's see here. The positive output's down here. Labeling is way too small. Need to fix that. Okay. Okay, so this is positive. I'm thinking to keep it... Oh, nope, that didn't work. Keep it cheap, CJ, and then they'll all be green terminals like this, because those are the most mass-produced. I might make this one orange, this one over here. And maybe these white. I don't know. It all depends on pricing. For this product, pricing is most important. So if it raises the price, then I'll likely not do it. And I'd like to stick with raising clamp for these, but we'll have to see. So red should be the top one. Yeah, exactly, Monty. And as I said, for home use, I think using leaded solder is fine. Yes, Josh, he will carry my analog boards once they're released. Okay, and white goes in here. So I actually scaled these terminals up. They were 3.81 millimeter before, and they're 5.08 millimeter now. Yeah, that's all in there correctly. Now on this side, it's not really needed because you're basically going to connect an LED strip, not long wires. But on these, I believe you can get 14 gauge with a ferrule, because all the power will travel in a line, so having thick wires on these is going to be preferable, because you're not going to have the same voltage drop as on an LED strip. So like the 4 amp per injection rule and stuff like that shouldn't apply. Well, it's glasses time. This is a fully untested board. I haven't built one myself. There's a complete new buck converter on there with a new circuit. I don't know, man. Let's find out. Let's hook up the power supply. Possibly there, Neil. Possibly. I don't know. I actually don't know. I have no clue. So let's hook this up. So there's just a dig quad here, same we used before. Let's keep that in the screen. There. So VSET 24. And I'm limiting it to 1 amp right now. Can I screw anything up? Don't think so. Let's see if it explodes. Oh wow. The LED strip is displaying, I think, supposedly orange. I don't know. Oh, it's limited to 1 amp. Let's limit it to 3 amps. Yeah, I don't actually know. Anyway, let's see if it came online. It's already doing more than the last board. 10, 24, 1, 108. Okay, let me check. Okay, we have WLED. So let's go to red. Let's show you the LED strip too a little bit. Okay, let's first lower the brightness, see if that works. Oh, it kind of works. Let's go to red. So that's red. Okay. Blue. Okay. Green. Okay, kind of works. But white's on too. Why is white on? Anyway, so, okay. And red is on full power. That's a screw terminal free version, but then you just solder the wires in, or let me check how this is set. Oh, that's wrong. Okay, there we go. SK6812. We have 1 LED. Save. That might be the issue, actually. So red, blue, that's now white. Right, so green and... Okay, we need to fix that. Green and white need to swap. White and green. Save. Let's go back. Red. Blue. Green. And white. But of course white's now doing all the colors. Because I need to change... I think this needs to be set to accurate. Yes, and now I have all the white LEDs. So red, blue, green, and this is white, and this is just the white diodes. Let's try and lower the brightness. Oh, Johnny Bergdahl's here, right? When we're testing. So far, this seems to be working somewhat, kind of. So let's zoom this out a little bit more. Let's do it again. Red. But red is like fully on an instant switch. I'm not sure what's going on there. So red is, it knows it needs to display red. But it's on or off. That's it. No, nothing in between. Okay, blue. Blue, on the other hand, you can lower lower brightness and raise brightness. Yeah, see, that works. So this is very... Oh, you can't actually see that, right? There's the brightness. So blue, I can, you know, change the brightness, and that actually works. This is using about 20 watt, if I remember correctly. That's about correct. And if I turn it off now, how much is it using? 1.19. Still a lot. Okay. Green. Yeah, green works correctly too. Seems to, I think. And then white. We just get the white diodes. And that works perfectly. So I kind of expected this. But I'll likely have to change the resistors per color value to match it better to how much current the WS2814 is outputting for that color. Yeah, I got the fiber internets there, Johnny. Yeah, but this seems to be working. Awesome. Green. And that switch isn't great. Still, this works. Blue. And red is just on. Doesn't matter what I do. So that likely needs a different pull-up resistor to make that function correctly. Still no smoke. Aw. Well, no smoke here either, except flux smoke. Well, in the end, if it works, it's kind of boring, because then it just works. Let's take a look at the temperature the board is running at, because I have a sneaking suspicion it might... Well, it should be cooler than last time. Oh, wow, this actually also means that the whole buck converter thing I built also works. Right? So let's remove that browser real quick. Well, they're not on, so, you know, Emil. Put it on main power if too boring. Yeah. Let me fix this real quick. There. So, right now, what we're seeing is... Yes, that's what I expected, or hoped for, actually. So the board is a lot cooler, as you can see. It's about 36 degrees. That's because the buck converter, and that's this chip over here. That's taking all the load now, so that's doing it much more efficiently than the LDO was before. And we see 4 warm resistors, and those are the pull-ups and pulls downs that I need to use to invert the signal and things like that. So those are now hot, and you'll see that if I enable power, and let's do white at full power, one of those should actually cool down. Yeah, you see here, the bottom one is now cool. It's now gone. It's not warm anymore. And if I turn off the LED again, there it comes back up. So that's basically wasting power to keep the LED off. And it's a bit too hard to explain the circuit in that sense. But let's turn it on again. And you immediately see that it cools down. And it's not creating heat anymore. And thus it's also not wasting power anymore. So that's an important one. So I'll see which values work there and work best. But before I had those in the resistor network and in the wrong spot. And there was problems with that basically. But now that they're single resistors, I can just replace them and try different values per channel, which is optimized for that specific channel. Because now, let's say if we do red, turn on the power, there, top one goes out. See that? That one disappeared. And if we do blue, the one below that disappears. And then if we do green, the one below that disappears. So that's all the individual channels. And then the resistors I have on there, which I can now, manipulate. Let's do 2 colors. There, 2 are gone. We're making a board that takes in a digital signal and then makes it analog PWM so we can dim generic analog LED strip. But it still needs some fine-tuning there. Because some parts are getting too warm and, wasting energy. It's funny looking at the resistors. I'm also glad to see the MOSFETs aren't heating up at all. Because we're currently drawing 1 amp. 1 amp isn't that much, of course, but, Thanks there, Steve. Appreciate that. Yeah, so this prototype is basically doing what it should. It just needs optimization, and that's why I built it like this. So that I can actually, optimize the components in real life, and then it'll probably be close to shipping. Because I need to do some scoping and stuff like that, but the buck converter also seems to be working just fine. Right? Because, it's working. Let's see what voltage it's outputting. Because it's tuned for 10 volt, but of course we have that 5% resistor on there, so it might actually be doing something different. Where to measure that? So let's see. Oh wait. I need to. There. Now you can also all enjoy what I'm seeing. So let's see if positive is 24 volt. It is after the fuse, so that's good. And then it should also be here, of course. Yeah, that is good. Now I wonder what the output pin is, but I don't need the output pin. I think I can use this side of this resistor. Excellent. 9.952. And I wanted 10 volts. Nice. Yep, power LED is also working. It's not too bright. Slightly, but it's okay. Well, Aditya, sometimes you might want, I don't know, 50 analog channels for a project you're doing, And then you can use digital data from a board that has an ESP32 on there and fuses and LEDs and level shifters and things like that, to make it analog again for certain situations, basically. So I already have a lot of digital boards with ESP32s and Ethernets and all kinds of stuff. Quinder has to reach the level we will not see the magic smoke. Yeah, sorry about that. So let's see if we have positive over here. Yeah, 0 voltage drop. That's cool. Yeah, so the board is dropping no voltage at all. So let's see if we turn everything off. If we turn everything off, we're drawing 1.19 watts. That's better than it was before. But if we disconnect the board, we're drawing 0.71 watts. So 0.71, whoa, that was a giant flash, to so that's half a watt. We're drawing 0.5 watt. It's not too bad. Could be better, I think. Now we need a board that takes inputs from 50 analog boards to drive one digital strip? What? What? I wouldn't even know where to begin. No, that's reversed. Okay. Yeah, that's also correct. So then let's do here and here. So that's 10, that's correct. Okay, and this is 10, yeah, and that's why that resistor is getting warm. Right. Okay, well, I'll have to play with resistors, right? But I'd say this board is already a lot better than the previous attempt. And with a $5 buck, or $5 buck converter on there, that ain't too bad. Yeah, red needs fixing. Well, I don't really have a target there, CJ, but it kind of depends on the MOSFETs and what they'll take. So I'll have to scope it up to see what's actually coming out with different resistor values, and then kind of optimize it, basically. Oh, wow. I'm not sure what's happening now. But the LED strip is flickering. That's not good. Yeah, that's not good. Why is it doing that? What? Okay. Are all colors doing that? No. White's perfectly fine. Blue isn't happy green. Yeah, green's fine too. So I need to fine tune some resistors there because blue and red clearly need different values. Must be Ziggo hacking into the controller, yeah. Glass is back on. No, I don't think it'll explode. It's not that hot anyway, so. You can see the PWM slightly, because this is PWMing at around 2 kilohertz. I'll have to measure that later too. But you can see it slightly here in the video, I think. It's not that obvious. Yeah, okay, like this you can see it. Because if I turn it off, yeah, that's gone. Because my other lights are PWMing way higher. Yeah, I basically have to mess with the resistors to determine the ideal values there. Hey, Luke Mark is here. Maybe the switch? No, the switch is fine. So this switch is to determine if the bottom side takes in the data and then the top side puts out the data, or if you want to mount the board this way, then you can flip the switch to like so, and then this takes in the data and that outputs the data. So then it depends on your project if you have the output on this side or the output on this side. And if I now change anything, nothing will happen because it's not getting data. Yeah, nothing happens. But as soon as I switch this switch here, it gets the data again and it works fine. Yeah, but this is already a lot closer in regards to prototype to a working version. This just needs some little fine-tuning, and then we're there. As BitLooney would say, ship it! It's ready for shipping immediately. Yeah, and because we don't have the LDO pumping massive amounts of heat into the board is now a lot cooler. And we have some, as I said, some resistors that are warm. But that's fine. Yeah, there's something up with that red channel, because now the resistor for the red one is also off, which is not correct. So let's turn that on again. Oh, it flares up the MOSFET, I think. Well, it's 1.12 amps, so the MOSFET got hot a little bit during the transition. But now it's just on and it's fine. Wow, okay. That's so odd. Something is odd there. That needs fixing. So, the actual color or the brightness doesn't change. But if I flip the channel, the MOSFET does light up. No, it doesn't anymore for some reason. That's so odd. Let's go to blue. See how it flares up like that, but the others don't? But the red channel has the exact same circuit as all the other ones, and especially the white channel is working perfectly. So for the white channel, these resistor choices seem fine. Yeah, but like for blue, it needs some optimization there because it starts flickering and stuff. Green is fairly okay. But if I now switch on red, I need to switch on red to a low value. So let's switch that out and switch to red. Okay, it doesn't do it anymore. Well, the MOSFET flares up. I know, it needs some fixing. 2 kilohertz, yep. Yeah, so this is just another option. I don't imagine this will sell thousands of boards. It was kind of a fun project to come up with and do. Um, but I do see actual use cases for it where, like CJ said, you have a staircase, for instance, and you don't want to snake the data around the stairs, or it's impractical to do that, or you want like 5 meters of strip per step. Why is it not focusing? Or, you have a cabinet where you want a lot of RGBW channels and you don't want to use digital, or there's reasons to do that, so. But yeah, this works great. Oh, and CJ, I've actually been thinking of improvements here. You mentioned the fuse, that might be a limiting factor. I've actually been thinking, since we now have these pins poking out of the bottom anyway, I could just make another set of pads for the fuse on the bottom side, and then if you wanted to modify it and put 2 fuses on there, and they'll add to each other, you could put another 3 amp fuse on the bottom, and then it could do 6 amps, depending if the channels handle that, of course, but they should. And also, there's currently no flyback diodes on there, because this is meant as an LED driver, not a motor driver. But I could put pads on the back per channel to, have a flyback diode on there if you want to, but you have to solder them on yourself. But I could at least provide the option for free. It doesn't cost me anything making those pads, so yeah. Other than that, I think this is working pretty well. Yeah. Very nice. Okay, now I'm just playing with it. Can I test the power injection terminals too? How would I test those? Well, I could just use a set of wires and not connect these. Right? So not connect the front ones, but they're all connected into the same plane there, CJ. There's nothing between this positive and that positive and that positive. There's nothing in between there. Same with the negative. It's all a shared ground plane. So, I mean, this is all nice and ground. And we already measured voltage, and as I said, or you could see, the voltage on the input terminals is exactly 23.950, which is exactly the same as on these terminals. Oh, we lost 1 microvolt, or what is it? 0.001. And it should be the same over here too. Yeah. So you can string a lot more of these along than LED strip, because you're not limited to 4 amps. This will do 10 amps easily through the board, or maybe even 15, without as much voltage drop as an LED strip would have. The same rules don't apply. And I also like how all the components are now basically guarded by the terminals. It's not easy to accidentally touch them. This one is slightly more exposed, but yeah, it's okay. This one is slightly exposed because the fuse is here, and this is ground, and this one isn't, of course. But it should still be fine. These are all M3 screw holes, so those should be fairly easy to use. I actually thought of a solution for that. Where did I put those? Huh. One moment, please. Oh, and then we'll get to the secret. Where did I put those? So, to screw this down, I first wanted to make an completely SMD version, so it didn't have anything on the back. But that didn't work out. So now we have these pokey pins there, which carry all power and things like that. Now, this board doesn't have fuses on purpose, because I expect you to use it with something like a Dig Quad or a Dig Uno, which has the fuses. So the power lines traveling along the boards are protected by the fuse where the power line starts. And then, to make sure one board doesn't overload or short circuit anything, whatever, there is a fuse on the board here, but that only fuses this output and the rest of the electronics on the board. So, yeah, there is an idea behind that, why there isn't a fuse linking the boards, because then it would be very limiting, and right now it's not limiting. So, but you still have those pesky issues on the bottom where those pins poke out. So you can get a bag of these. Hold on, I'll show you in a second. That button on the ESP32? Oh, yeah, this one's slightly mangled, because this is an ESP32 I've been using for quite a while, and a lot of... there! I fixed it. It's just a little metal housing. Anyway, fuses are for the weak, yeah, or for the smart people. Depends on how you look at it. You can get feet like this. Right? And a bag of those feet, like 50, cost like $1, maybe $2. I don't even remember. They're very cheap. And then you can just, I don't think these, oh, these are magnetic. Nice. You know, put it, ooh, don't touch the fuse. Hope it's not touching the fuse. It's not touching the fuse. Good. You can just put it through there. The smart thing to do is to not do this while it's on. Of course, oh. Well, we almost had magic smoke. I did it while it was on and it short-circuited, but it recovered. Let's try it again. There. So you can get these little feet. You can use standoffs to stack them too. Yeah, sure. And then they'll even have shared ground. Not sure what that's good for in this case, but you know. So I just want to do this real quick for fun. And then we'll look at the secret. No glasses! Yeah, it actually turned off, but then it turned on again, got a new data signal, and it just worked. So, let me screw in these feet here. And again, normally you'd absolutely do this without power on the board. Just being stupid. Add Q power post to shit. No. But then you'd also need the data signal and no. If you really want to create a stack of them, you can just loop the data signal. Or you can actually loop it, because you can, the top board can be bottom in, top out, and then the board below that, and if you stack it with ground shared, and power then, you can just loop it like that, because then the board below that can be top in and bottom out, and then below that can be bottom in, top out, and so you can make very short little cables going down. Anyway, because I made these M3 screws, they're a bit high, but as I mentioned, I might put some components or component spots on the back if you really wanted to use those for certain cases, and then you can just use this little feet and screw these into the board or whatever you're working on. I don't know why they want to stack these, Emil, but and these are cheap. Let me Let me look these up. These are really cheap. Let's see. Here we go. They are 38 cents US. Oh, with $4 shipping. Okay, that sucks. Let me see. Is there a related item? No, okay. Yeah. But anyway, they're like $5 a bag for 40 of them. So you can mount, you know, lots of these boards. And you don't need to use 4 feet. You can use 2. That's fine as long as there's not a lot of tension on them. That's fine. I might want to make a little bit more distance here. Not sure how I'm going to do that. Probably move it more into the screw terminal. Because I can't really make more distance here. Over here it's fine. This is fine. But this is kind of, you know... might want a little bit more tolerance there. So I'll have to see about moving this slightly that way and then it's fine. Right? That's a bit low tolerance. But yeah, using these little feet, yeah, you should be easily able to mount them. I could go to M2.5, but then I've used M2.5 before, and then people complained that I was using M2.5 and not M3. And I get that because, for instance, these feet, you can get an M3 and up, but not an M2.5. So, in that sense, I get it. Plug the hole. 3 is enough. Yeah, that's an option too. Sure. 2 is enough, actually. I mean, then it's pretty stable. But 3 is, yeah. No, well, I could rotate the fuse. I'd have to see if I can actually fit that in between those screw terminals there. Because otherwise I don't have enough room to run the voltage planes and have a ground guarding outside of it. But that's, you know, more of a PCB thingy. But yeah, we'll see. You can bridge the fuse, sure. But as I said, to accommodate for more power, because I think 3 amps normally should be plenty, I'll probably put a pad on the back in the same spot. And you can put another PTC there yourself, and then you could raise the power to 6 amps. Right? But then one of these MOSFETs won't do 6 amps, I think. I haven't tested it yet, but, you know. Oh! Should we test that? Let's do it. Let's test it. Let's test a high power strip on one of the outputs, on the white output. And then we'll go to the secret. I want to test it, so... It also makes it a lot more stable to screw. Right. High power strip. Let's get one. I don't need to get one. I'll just use one of my abused testing strips. It's such a giant mess over here. There. Let's see here. So we have positive. And then we have negative. Nope. There. Good. Okay. So this is a 28.8 watt strip or thereabout. The power supply, let's limit it at 5 amps. There. Okay, let's turn it on. Nothing so far, of course. That's good. Let's set WLED to white. Oh, let's refresh it. There. Oh, you can't actually see it, can you? So we're currently drawing 0.41 amps, and it's down really low. Phoenix connector's too expensive. You could prepare strips on the workbench and glue them in. Yeah, well, I worked with that before, but then it would make the board a lot bigger, because you know they'd stick out. So that's why I kind of went back to screw terminals instead of using Phoenix terminals, because you might want to put this in spots where you don't have a lot of space. And these feet are kind of big. But there's also a different variant, like, let's see here, like these. These are also for M3, I believe. I have to verify, but I think so. And those are just sticky pads. So they'll sticky underneath the board, basically, and they're nylon, so they're not metal either. Oh, somebody actually mentioned that, of course. That's right, Mr. Blue, yeah. So you can also use these sticky pads and then it'll stick down wherever you need it. So, and that should still raise it up enough. You can get them in different heights. So anyway, we were testing power. We're currently doing 0.41 amps. Let's give it a bit more. Okay, we're now doing 1.61 amps. 2.47. Okay, let's leave it at that for a little bit. I need to get the LED strip out of the screen. Okay, yeah, that makes sense. Let me try and show you. So this down here is the PTC, and that's currently at 40 degrees. It's about 25 degrees, 26 degrees ambient in here. So this is at 40 degrees, but we're doing 2.5 amps, and this is a 3 amp hold PTC, so that's normal. And then the MOSFET with 2.5 amps is 43 degrees. That's not too bad. Let's go higher. Okay, and we're now at 3.03 amps. Let's go full power. Yeah, we're now at 3.39 amps. Well, the MOSFET's not really caring, is it? As you can see on my face, there's a lot of light here. Because this is 81 watts that it's now drawing. Oh, wait. We also have these tiny little wires here. I forgot about that. It's not too bad. The ESP itself is warmest. And then the power regulator over there. But yeah, these tiny little wires aren't heating up that much. That's good. You can't even see the data wire. The data wire is here in between, but you can't see it because it doesn't light up. And this is the positive wire. Yeah, 31 something. And this is the negative wire. You can see it going into connector. Oh, the connector's warming up. It's 40 degrees over here. That's also why you should always use the same diameter, positive and negative. I mean, here you can perfectly see it. Those are heating up at 3 amps. 3.45 we're currently using, 82 watts. Anyway, the board, the PTC will slowly start warming up. 44. MOSFET doesn't really care. During lower loads, sure, let's go to 50%. But the switching frequency is only 2 kilohertz, so MOSFET shouldn't be strained too much. Although there's kind of limiting resistors everywhere, so in that sense it does, you know, make it harder on them. I'm gonna hook up another strip. let's blow this thing. Let's hook up this strip too. Let's see if we can get it in there together. We should, I think. Yeah. So I've strips I've been using for a while now, just strung up here in my office to do lots of power testing on analog LEDs. So these terminals are kind of nice because you can get a lot of wire in there. Yeah, I can. Oh, right. Well, let's see what overheats first. These little wires here. Oh, they're kind of supple. Or the board. Okay, let's go. Okay. Let's go to white. There. And let's go to full power immediately. Oh. No, wait. It's not working. Why isn't... Uh-oh. You guys weren't paying attention, were you? See this? That's the negative wire. But then again, with analog or dumb LEDs, that's not too big of a deal. And my analog boards would actually have turned off the channel because there's protective measures for that. But this board is a bit simpler in that sense. Oh. Okay. Sure, let's do it. Bam. Okay. Yes. Now we're at 50% load and it's already at 57 watts. Oh yeah, there we go. We're drawing 5 amps. Hold on. $118 watts. So, oh, the MOSFET still doesn't care. So the MOSFET is about 40 something. Hold on. There. Yeah, MOSFET is about 49, 50, 55. Okay, well, it's heating up, but it's doing 5 amps now, so 120 watts. But the PTC is like, hey, wait a minute. That will slowly keep rising until 115-ish or so, and then it should shut off. It's funny, you can actually see that only half of the package, if you look right, is heating up because that's the one driving the MOSFET and the other half is doing something else. Yeah, one of the things why this is working so well is because I'm using 10 volt on the gate of the MOSFET and it's only 2 kilohertz, so that helps it out a lot. Let's dim it down to a little bit less, see if the MOSFET heats up. Not really. Okay, max power, 5 amps, 120 watts. Yeah, if you're diagnosing stuff there, Monty, they are very nice to have. This one isn't great, because if you do the other modes, like the picture-in-picture or the mix mode, you can see that it doesn't really line up, and you can move the image around, but it only lines up at like this distance. Almost. No, okay, well, let me... Can I focus on that? Right, so as you can see on the image, I need to hold it really high, and then the IR and the photo image line up, and I can adjust it like that. Right, so that's almost aligned. but it needs this distance basically to line up. And I don't want this distance, I want this distance. But then it doesn't line up at all, it's just all bogus, right? Doesn't you know, doesn't make sense at all. So I just generally use IR mode, and then it's okay. This phone was about $380 on special, and it has the IR thing built in. It's a Doji S98 Pro on AliExpress. We're still doing 5 amps there. This is a good fuse. Nah, that's just how these things work. Oh wait, how warm are my cables? Oh, the cable is also 50 degrees. Yeah, that's going to be dropping some voltage too. Yeah. Okay, let's do what CJ has been mentioning. Let's put an extra injection wire in there. Let me get a wire real quick. Something like this should do. So the idea is that if you have several of these boards strung along and you're running into power drop issues or your wires aren't good enough anymore, you can just add some wires into these terminals. Where's my... there. Oh no, I bent it. Come on. This board has been through hell. Oh, okay. The production boards have better terminals now. There. Oh. So I just added a power injection wire from here, also from another fuse, and then you can just, you know, string this along to where you need it, and then add it in here, like so. Oh, these weren't opened yet. We talked about the floating heart. Hey there, Jeff. Yeah, that's a new YouTube feature. But it's kind of, yeah, ill-placed. There. That should allow a lot more power to make it into the board, because now we don't have to rely on these flimsy little cables here. We have these thick boys, and the data is still going through there. So let's see, like that. Power it on. Yeah, I know it, but that's where my chat overlay is. That's the problem. Okay, let's go to white. There, full power. Okay, we weren't voltage dropping because it's still at 5 amps. But now at least those wires should stay a little bit cooler. The PTC is warmed up immediately again. Also nice to see that the board, well, where the PTC is, it'll heat up, but that's logical, of course, because that's the hottest component on there. But the rest of the board is perfectly fine. It's not showing any hot spots for transferring 5 amps of power. These are still kind of hot, but you know, the others should work now too. But the cable is a lot longer, but also a lot thicker, so I don't know what that works out to in regards to resistance, but let's disconnect positive for fun. Oh, that's true. That's true there, CJ. Except then it's not fused. That's the biggest issue, but yeah. That could be a nice hack. Well, you can see the amount of light over here. So, let's have a look. Those small wires should now, well, one of them is cooled off. This one's still transferring power, but the rest of the power is coming through the injection terminals. Well, I guess we should also be able to disconnect negative then. Let's do that on this side. There. Oh, no. Data signal not liking that. Okay, it's confused. So it does need the negative next to the data signal, which kind of makes sense. How are the YouTube stats? Let's take a look at the stats. We have 0 dropped frames and still doing double the bit rate. Nice. Let's turn it on again. Oh, I probably needed to flip the resistor switcher when I disconnected the ground next to the data wire. Anyway, this is working. Even 5 amps is no problem. Oh, we're not at 5 amps there. Eventually, the PTC will probably overheat and then close. It's gonna take a while. Okay, you want me to hook up one more strip and then I'm really done. Then we're gonna look at the secret. So let's do what CJ said. Let's abuse one of these terminals for positive. There's a giant solar blob on this one. There. Oh, but then the positive isn't going through the PTC, and we kind of want to test the PTC. Okay, so we need to put it in here. Let's see if we can get 3 wires squished into there. Take this one out first. Add that one. And then add this one. That's kind of jank. Yeah, sure, let's add this one in here. Because why not? There. Now it's totally jank. Power on. That's all the reds out together. It should be good. White. Huh? It's still at exactly 5 amps. Well, that's likely because this guy is just like, nope, nope. I'm a 3 amp fuse, man. You're not getting more than 5 amps. Yep, no, it's just like, nope, nope, not doing it. So let's move one of the positives to the terminal CJ mentioned, just to, you know, have fun with it. Oh. This one. Yes, the fuse is refusing. And actually, oh no, I was gonna say if we draw more than 5 amps, this fuse at some point will also pop, but not that quickly. They're slow blow fuses. So let's keep it like that. Let's power that on. There. Oh, what? Why are we still at 5 amps? Oh. My bench power supply is set to max 5 amps. Okay, let's back it off. I set 10. There. Now we can do 10 amps. Okay. So let's go. Oh yeah, now we're at 5.13. Oh, yeah. The fuse on the dig quad was like, nope, nope, you're at 6 amps, and it's gone. Okay, let's replace that one. Oh, it's in there tight. Come on. There. We should have a fix for that right over here. Oh, look at that. A 10 amp fuse. There. That should be fixed. Let's also reconnect the positive wire just for fun. See if it starts to melt at some point. Right? There. So now we have 2 LED strips connected here and one here that bypasses the fuse. But everything is still going through that single tiny little MOSFET there. That's going to have a hard time. So let's get the thermal camera out. Hey there, DJS. You mean these? These are little fuse with little, like Littel fuse, little fuse, but they're a very known brand. So I only include high quality official name brand fuses because they work a lot better than generic AliExpress fuses, that's for sure. Because this one just popped with 6 or 6.5 amps. So, okay, 3.46 amps. Poor little MOSFET. Oh, there it goes. We're at 5.45 amps. Poor little MOSFETs be like, oh no, we be 60 degrees, man. Of course, not everything's going through the PTC, so that's staying a little bit cooler. Okay, let's go even higher. Okay, we're at 160 watts or 6.63 amps. MOSFET be like, yo, I'm like 60 something degrees. Sure, no problem, DGS. Okay, full power. 175 watts or 7.32 amps. So let's look at the cables. Well, this cable's getting pretty hot. That's ground, and that's positive over there. But then again, the injection wires are like, well, we don't care. But those are a lot thicker, so 80 degrees. And this one's only 60 something, but of course a lot of power is being bypassed now, so I'm actually surprised this MOSFET's doing 7 amps. Because in reality they only need to do like 2, maybe 3 amps max. $86 degrees. Yeah, that's getting pretty toasty. Okay, and now, okay, let's turn that off. And then the real last test is forcing it all through this PTC here, because I would have kind of expected it to start limiting or, well, shut down. So let's try and squeeze this one in here again. There. Okay. Everything's going through the PTC. Touch it, touch it. No. That's bad. Let's see. White. Is this enabled? Yes. Okay, so currently the MOSFET is highest, but it's only doing 3.47. Let's go to full power. 7.16. This little fuse here should... Oh, there we go. Okay, yeah, it's heating up 80 degrees. Yeah. So now it's already warmer than the MOSFET. There. 90, 94. And there we go. 115. And you can see the LEDs. They're not fully turned off. As you can see here, there's still some light on them. But we're currently only drawing 0.4 amps. So it's letting some power through, but not a lot. And while it stays this hot, it's basically in a short or a non-short condition, I guess. So if we now lower power, we can slowly see 0.57. That's not enough. So it'll start cooling down. Yeah, it's cooled down. And now it should be closed again, or let power through. Yeah, now we can run power through it again. So now we're at 3.62 amps. Yeah, exactly. Yeah, Dutch Taurus. So we're at 5.27. And you can see the temperature climbing slowly. And once it hits that 115, it shuts off. There we go. Power shut off. 0.43 watts. But actually the electronics on the board are still functional. So that's why I can turn down the brightness and then you'll see the temperature start decreasing, and now I can actually turn it up again, and it'll let the power through again. So that's how a auto reset fuse works. Cool. That works well. So right now we're trying to do it in a scenario where we run too much power through it. Normally in a short scenario, you'd have a spike of like 10 or 15 or 20 amps or something like that. And then it would basically, well, not instantly, but almost instantly close or like pop, you know, like a normal fuse would. So yeah, that is working great. And also this board itself didn't heat up at all, running 7 to 8 amps to it. So the power planes are all good. And even that little MOSFET there is a big champ. It did get up to 80 degrees at like 7 amps, but as I said, you shouldn't run this above 2 or 3 amps per MOSFET anyway. Basically, the board is officially limited to 3 amps, so they should never see more than 3 amps a piece or in total. And the idea is to have multiple of those, and then each board will have a protected output, and you'll have a DIG quad or a DIG Uno or a DIG Octa, which then has the line fuse for the power injections, so that if a short happens on the line side, this fuse protects these lines and this part of the board basically, and then this fuse protects all the electronics, and there's a buck converter which has reverse polarity protection and things like that too, and it protects the output and that side basically. So because if a short happened here and you'd have a 10 amp fuse over here, maybe that short's only 5 amps or 6 amps or something like that, and that could still be an issue in regards to creating a fire on the LED strip or somewhere else. So that's why I have a 3 amp fuse here, and the other side is protected by a much higher amp fuse, but then these wires can also handle a much higher amperage. So yeah, that's the idea. So that's all working pretty well. Now I just need to play with resistor values to optimize each channel. And then I think we pretty much have a working board. Because so far, this little tiny 200 milliamp buck converter there didn't heat up, didn't do anything strange. Power was stable, even during stressful situations. Because the power for this thing is running through that PTC, so but it remained online. So yeah, that is actually pretty good. And we don't have that giant heat from the LDO anymore. Yeah, exactly there, Johnny and Dutch Towers, both right. So, we've been going for 3 hours and 8 minutes. Holy shit. What? 3 hours and 8 minutes? Ooh. Are we going for the longest stream again? We still have 61 people here. I guess they rejoined for the secret. But first I want a bit of Coke, because I've been talking for 3 hours. Abuse the board. What more do you want to abuse? We ran almost 2.5 times the current it's rated for through it. Could you please tell us on stream which effect is running on each of the 4 channels behind you? Every one of your stream I try to figure out on how to replicate them. Oh wow. I don't actually know, because this is a preset I made like eons ago. So let me check. So segment 1 is doing Pride 2015. Segment 0 is doing Pride 2015. Segment 1 is doing Ripple. Segment 2 is doing Synalon Dual. And then segment 3 is doing Theater. Yeah. WS2814, you pick SK6812 there, built by Ross. And then, just like I had to do in the stream, you probably have to switch the green and the white channel out. Yeah, Pride 2015 is this one. This one over here. Yeah. So this one's Pride 2015. This one is Ripple. This one is Sign-Alon Dual. Yeah, with the two thingies going like that. And then this one is Theater. That one. I can up the brightness a little bit. That sometimes changes the effects a bit. But yeah. I generally have it set pretty low. Okay. So, Emil Bart, it's funny you mentioned that. Let me turn my power supply off here because it's making noise. It's not turning off? Oh, it is. What? Okay. So, the secret of the day, we have to switch back to this view. Sometimes you want to get a data signal to where it just doesn't want to go, right? Because it's too far. Generally, I say up to 10 meters or 32 feet with the tuned stages on the Dig Quad, Dig Octa, and Dig Uno, and, well, not so much the Dig to Go. That has a different level shifter stage on there. But with those tuned boards, you can get a pretty good distance. Like, as I said, 10 meters or 32 feet, you can generally get away with when it's working fine. Especially now we have the resistor switcher and things like that. But in some situations, you just need to be sure that data will arrive. So, I've made two little boards. We've got this board. And, let me zoom in there, because it's really tiny. Again, I messed up on the text, thinking like, oh, it's huge on my screen. And then, you know, on the board, it's almost too tiny to read. So this takes in positive, negative, and data. And then it does some magic to that. And then it comes out as RJ45. And I don't have an Ethernet cable on my desk right now. And, well, then you put an Ethernet cable on here. And we're going to test, I think next stream, how far we can push that. And then there is a second board, which has bigger text. So this is the Quinled Data Diff. It's a working name. Receiver 1. And it says there, not Ethernet, RS485. So remember that. You plug in the other side of the Ethernet cable. You plug in your power wires, and those can be 5 volt, 12 volt, or 24 volt, independent of what voltage this side is running at. And there's a little fuse in there. So there's a little fuse holder, there's a little cap in there, there's a level shifter, and a resistor. And then it outputs LED data again. No, Emil Bart, no. There's no positive on there. There's also no ground in there. No. So, you know, you can link these together with Ethernet over here. And in theory, you can go 100 meters, no problem, and have the data arrive there safely, be transformed back into the data or LED strips love, and then it'll just work. So, yeah. That is the secret of the day. It's something I'm working on. Now, this is a one-channel version, and it has some neat features like, if you look here, you have these two M3 again screw holes, so you can actually use those same little legs we showed before. We'll test that in this stream because I actually was anxious to test that soon. So let's take two of these little legs. There. And the idea is that you can screw them in and then it's not going to interfere with anything after that. So let's say you mount this down. So let's remove these wires. No, there's no ground in there, although you can enable ground. But currently there's no ground on the cable, but I do have a solder bridge here if you want to make the unused pairs in this board ground, but currently they're not. So the idea is that you can put these little screws through here, and then put the feet on there. No, this is using pair 1 and 2. And then I'm looking at making a 2-port and a 4-port, and that would use 1 and 2 and 3 and 6. And then, you know, the rest. But it's not doing DMX, it's doing RS485. Where's my screwdriver? Oh, yeah, here. It's not doing DMX there, Emilbart. Why is this so hard? Oh, okay. I'll do it manually. There. Well, I guess we could point the feet like that, and the other one like this. So I haven't actually tested the feet yet, but in theory that should work. There. So now it has little feet. And you can still put the wires in no problem, like that. Oh, I'm stabbing myself here. Okay, so they're not touching, it seems, so that's good. And you can easily get the wires in there. Currently, I think the screw hole is ground. I might need to remove that, because if it accidentally touches, it could be an issue. Sure. Doesn't need to be ground in theory. So the feet are working nicely, and I should still also be able to get an Ethernet cable in there, because I made sure to get a socket, which is especially undeep. It's also plastic, and it has the clip on the top instead of the bottom. So let's get an Ethernet cable real quick. Let's see if it goes in there. And it does. Yep. It's a tight fit, but it works. There. Right? I'll have to test that with different Ethernet cables. But yeah, that's the idea. So there. Right? So you can have a feet on both of these so that you can actually mount them down. But then they're in a place that doesn't really make the board much bigger, because you're going to have cables coming out of both ways anyway. And that way you still have mounting options. This is the rigorous testing and control you were telling me about yesterday in a call. Oh, well, part of it, yeah. So yeah, if you need to transport your data a long ways using Ethernet, I'm working on some solutions for that. Of course, this isn't anything new. You can already buy solutions for this, but this is my version of that solution. And I think having good mounting options, for instance, and things like that, or having a fuse and a decent level shifter and resistor and data shifter stage on the output version, you know, it's going to make a difference versus what you can buy generally. Yes, no problem there, Jeff Hammer. So currently, and I'm still working on that, this sender board can do 5 volt or 12 volt. So you have your dig quad here, and that's outputting 5 volt or 12 volt. You can just hook it up directly, and you hook up a data wire, and then this transports over, you know, the cable over Ethernet UTP, or not Ethernet, over RJ45 8-pin Ethernet cable, but it's not running network Ethernet, TCP/IP, whatever. And then it plugs in here, and this is fully separated. So here you can run 5 volt, 12 volt, or 24 volt, and in theory, but this version isn't that, I should be able to make a a 48 volt version, because the capacitor on here is already 63 volt. All the other capacitors are also 48 volt compatible. That's not a problem. The only problem is the actual fuse. And why is that a problem? If you look on here, does it say? Yeah, it does say. So these fuses are normally meant for car usage. And it's a bit hard to highlight it. Yeah, there it is over here with my nail. These fuses are up to 32 volt. So the only thing not making this board 48 volt compatible is the actual fuse. Which is funny. Everything else is 48 volt compatible and shouldn't be a problem. I've taken precautions by using a custom footprint here that I use on more of my boards, where I can actually use a PTC like we have, for instance, on the analog boards here. And this JK6500 is a 60 volt 5 amp auto reset fuse. So we can actually solder this in place of this, and then you'll have a auto reset 5 amp 60 volt fuse. So then this is fully 48 volt compatible, right? But I don't have any 48 volt addressable LED strips, so currently that's not much of a concern. But I just wanted to have it available for in the future. Right, so I can easily, this is fully designed for 48 volt compatibility, and I can easily design it or release it so that it actually is compatible with that. But currently it's 5 volt, 12 volt, and 24 volt compatible. The Dig Uno comes with a 33 and 249 or resistor switcher, yes, Ducky Dev. Yeah. This one only has a 33 ohm, because most often this will be used with bundled cables. And if I had to build the option in here, it would just make the board a lot bigger and complexer. And I think that's more of a controller side thing than an accessory side thing. So, yeah. You can always use a data booster behind it and then do it that way. It's kind of cumbersome, but yeah. But the funny thing is, you can actually have a Dig Quad, then the sender board, 100 meter of UTP cable, receiver board, and then the dig to analog, and then you can run analog LED strips 100 meter away. So these actually combine pretty funnily. If you wanted to have garden lights 60 meters away, you just run a UTP cable up to there, have a power supply over there, and then you can choose if you want to have digital LEDs over there, just hook them up and it's controlled centrally. Or you can actually run like 5 or 10 analog LEDs, for instance, if you want to run it over there using one of these boards. So that all mixes and matches and works together. But yeah, that's the secret of the day. We're getting differential transfer boards. So that if you're having data issues, or you need data very far away, well, this will do it for you. Yeah, Ducky Dev, we talked about that yesterday, but yeah, there's a lot of research and testing that goes into that, but yeah. Yeah, this will do 100 meter, like 320 feet at least. I think it should. I haven't tested it yet. I haven't tested it on my desk. And I think we're going to do a live stream next week where we're going to test it with a bunch of cable I have here strung together and see how long it keeps working. And then I have a box of uncut UTP cable. We'll probably put some connectors on the whole spool and then see if it still works. I don't know. We'll have to see. But yeah, these are really, really tiny little boards. And this is about as tiny as I can make them, because they're basically the size of the UTP plug here, right? And this one is slightly bigger because it's basically, no, there we go. It's basically the size of the fuse. So hard to focus things sometimes. So it's basically the width of the fuse. So yeah. But they still have mounting holes and things like that. Thanks, Quinn. I just ordered a load of little fuses from CPC here in the UK. You saved me time and money. Thanks again. Awesome there, DJS. Yeah, little fuse can't go wrong. Those are awesome. And all of my boards, all of them, have little fuses on there. Because I just, you can't take a risk of fuses. I use some Chinese fuses myself, but we've also tested those on the stream like 2 years ago already or whatever. And we've seen that, or a year ago, I don't know when it was. But we've seen that some Chinese fuses are utter crap, and a 5 amp fuse will easily do 20 amps. So yeah. You can never use Ethernet as an all-in-one solution for VD and G wires, right? Or am I wrong? Hold on. What is my famous answer? Does anyone know? Does anyone in chat know what my famous answer to questions is? Somebody here must know. Come on. There's 59 people here. No. That means Google that for you is not my answer. It's close. Yeah, so I built it around RS485 10 megabits, so that should be fast enough for the data signal we're using. You also have slower chips, but I didn't want to risk it. Yeah. No, RTFM isn't it either. There's one saying I have. No, it's not. I will test it either. Exactly there, Soli. I have an article for that. Here's one of the newer articles, and it's why Ethernet cable isn't suitable for LEDs. And it goes into why Ethernet cable isn't ideal in regards to data signal and in regards to power, and it has lots of examples in there, etc., etc., explaining why it doesn't work, why PUE does work, and all kinds of other crap. So that should, inform you why Ethernet cable isn't the right cable for LEDs, unless you do this, and then it is. But that article will explain it perfectly. No, it's also not suitable for data. Ducky Dev. Or rather, it doesn't help anything for data. It's just as bad or as good as a normal wire. You win there, Solly. I don't have a prize for you, but, Yeah, but I'm really excited to be able to add stuff like this. And I'm thinking of maybe making a 2-port and a 4-port variant too. And maybe an ESP hat and, things like that. But to be able to add it to our arsenal, because, I think it could help in a lot of situations. So, 3 hours and 29 minutes. 1 minute. And we're going to end this show for today. Oh, I missed my music all this time. Oh, did I thank you for the donation there, DJS? Thank you. I think I did, but... So, that was a fun show. We did a lot of stuff. Built this thing. Right? And it worked, kind of. It worked a lot more than last time. So now it just needs some fine-tuning, but that's okay. And probably next week, we'll have to see. We're going to find out if this thing works. I think so. It bench tested okay. We'll see. We'll see. Okay, guys. I'm calling it quits. Thanks all for being here. Thanks for watching. See you guys next time. Bye-bye.